Hi everyone, welcome to episode 7 of my dev diary for Project Husky. Since I skipped doing a video last week, this video will cover the work I did in sprints 7 and 8. Last week I spent almost the entire time implementing a finite state machine and creating new AI behavior for prey animals. Unfortunately, that pretty much pushed out everything else, and I ended up with a buggy, unfinished system that would be difficult to show off in a video. I decided to skip the video and do a larger one in this sprint that would showcase more changes. I adapted the framework I created for the chasing behaviors from a few sprints ago and created a proper finite state machine to run the whole thing. For this behavior, which represents a small prey animal, such as a rabbit, I created 3 states: idle, fleeing, and hiding. The rabbit will switch to the fleeing state if a creature it classifies as an enemy gets too close. Once fleeing, the rabbit is looking for the safest direction away from the enemies, and searching for places to hide. If the hiding place is found, such as a small bush, the rabbit will head towards it and switch to the hide state once it reaches safety. In the hide state, the rabbit will stay quiet and observe its surroundings. If an enemy approaches too closely, it switches back to the flee state and resumes its run to safety, or a better hiding spot. One issue I ran into early in the development of the fleeing behavior was the tendency for the creature to get stuck in a logic loop. I'd programmed the AI to assess its surroundings and always head towards the biggest gap between threats. Unfortunately, in certain situations, the biggest gap would send the creature out of range of a threat and cause that direction to become the new biggest gap. So the creature would turn around and head back towards the threat, only to change its mind again and again and again. I eventually solved this issue by limiting the area that the creature can consider for a new path to a 120-degree arc in front of it, so it tends to ignore anything happening behind it. There's still quite a few bugs to sort out, but I'm pretty happy with the result. One of the cool things I implemented this sprint is a rustling effect whenever a creature gets close to a plant. I implemented this by modelling a damped spring and wobbling the bush in the same direction that the triggering creature was heading when it touched. I spent some time tuning the spring parameters and ended up with a rigid jostling motion that decays quite quickly. The whole reason I wanted to implement this effect was for it to look cool when the rabbit scampers over to hide in a bush. Unfortunately, there's a bug where the rabbit's colliders don't interact correctly with the bush and the rustling effect doesn't actually trigger. So basically, I implemented a feature that doesn't work for the one case I actually designed it for. I'm not quite sure how I'll tackle it yet, but I logged the bug and will address it in the future. Another cool feature I've been waiting to implement is to do an animation test of the creature's eyes. I've spent quite a bit of time offline doing creature design in the last few weeks, and coming up with rules for the different types of creatures and how to differentiate them visually. I created some eyes using some cylinder primitives and made a simple controller to allow the eyes to look around. Here you can see our old friends Alan and Jerry keeping a close eye on the player. I plan to eventually build a facial animation system to allow characters to express emotion and physical state, and this test is the first step along that journey. Lastly, I switched my basic 2D camera system to use the much more powerful cinemachine module instead. Cinemachine gives you amazing control over the camera and includes smoothing and dead zones and other cool features. I need to spend some time figuring out how to get the best results out of it, but the initial results are very promising. I'm not sure what I'm going to do with the mouse control system now though. On the one hand, I like the level of control and maneuverability it gives, but it also introduces some issues since the position that it uses as an anchor point for calculating the bearing for the player is no longer fixed and moves around. This interacts badly with the dead zone and leading logic that the camera is using, and leads to the player rapidly changing direction if the mouse is too close to the center of the screen. That's it for this fortnight. In the next sprint I'll be adding a few items to the game, and add the ability for characters to pick up and carry those items. Should be riveting. See you next time.